Hello ninth class students. Previously atoms and molecules was a separate chapter. What is inside an atom was a separate chapter, and chemical reactions and equations was a separate chapter. But now these atoms and molecules chapter has been combined with chemical equations. Okay, so in previous videos we have covered atoms and molecules and the chapter what is inside an atom. Now I am going to teach you the chemical equations and reactions separately. Okay, so for that first I'll be giving you the digital videos, then it is followed by my explanation, so that you can understand or just at least be familiar with the visuals which you see in the video, so that my explanation will be easy for you to grasp. Okay students, so watch these videos and try to save these videos in your pen drives, whatever digital content I am giving. For explanation part, anyhow I am there, you can use the Zoom sessions which are available with our classes.
Hello friends, this video on chemical reactions and equations part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 4. So here sulfuric acid is added to KOH, potassium hydroxide I think. This gives you potassium sulfate, K2SO4 plus water. Now again, if you see, is there any sulfate compound thing? Yes, we have SO4 here, SO4 here. That's my first priority. Then we'll take potassium and then hydrogen and oxygen. Correct. So we'll see the potassium part. So we have one here, it's all balanced, reactant and product. Second was the potassium part. There was only one potassium here, there's two potassium here. It is not balanced, right? So let's multiply this guy with 2 to balance it. So what you get now here is H2 SO4 plus 2 KOH gives K2SO4 plus H2O. Correct. Now let's again see the balanced part. Then we have SO4 K and H2O. Sulfate part is one here, reactant and product. Then we have this next is potassium part is 2 here and 2 here, all balanced. Hydrogen part, 2 hydrogen plus 2 hydrogen. We'll take hydrogen from here because OH was a compound, but still it is not here, so we are not considering this, right? So hydrogen 2 from here, 2 from here, 4 hydrogen, and here we have only 2 hydrogen. Correct? Does not balance, so we need 2 more hydrogen here, so we'll multiply with 2. So what you get now here is H2SO4 plus 2 KOH gives K2SO4 plus H2O, 2H2O. Now let's again check the balance thing. SO4 KHNO. Sulfate is 1 here, balanced. Potassium is 2 here, 2 here, balanced. Hydrogen is 2 plus 2 here, 4 here, and here also 4. Oxygen is 2 here, 2 here, and here also 2 oxygen. So if you see, everything is balanced, right? So this is also balanced equation. Let's take the last example of this balanced chemical equation. Little tricky, so please pay attention here. So we have PO4 both sides. So PO4 is my one compound. OH both sides, so we have OH also one compound. Then I'll take calcium. Then I'm left with hydrogen only, right? Correct, because this guy I took, calcium, hydrogen depending. These are my order of priority. Correct. So first let's check if they are balanced or not. So we'll take PO4. PO4, it has only one, it has 2. Correct, this reactant is product. This guy is 1, this guy is 2. Correct, so let's multiply this guy with 2. You get 2 PO4 both sides. So what you get is 2H3PO4 plus calcium hydroxide give HOH plus Ca3PO4 2. Now again let's compare. So PO4 we have 1 into 2 here. Here also we have 2. So PO4 is balanced. Now we'll see the OH part. OH part we have 2 here reactant. In product we have only 1. So that means this guy is also not balanced. So let's multiply this guy with 2. Correct? So what you get here is 2H3PO4 plus CaOH2 is equal to 2HOH plus Ca3PO42. Correct? Now let's again see PO4 OH CNH. So PO4 part, if you see 2 both sides. OH part there is 2 here. Calcium part is 1 calcium here, there is 3 calcium here. Right? 1 we have 3. So we'll multiply this guy with 3. Correct? Because it's not balanced. So what you get is 2H3PO4 plus 3CaOH2 gives 2HOH plus Ca3PO4. Let's again see the equations here. So again we have PO4, OH, Ca and H. So PO4 part we have 1 here, 1 into 2 here, and we have 2 here. OH part we have now 3 into 2, 6 OH we have. And here we have only 2 OH. It's not balanced, right? So let's again multiply this guy with 3. It's not balanced. So let's multiply this guy with 3. Correct? So let's see what you get. So now you get 2H3 PO4 plus 3 calcium hydroxide is equal to 6 HOH plus Ca3PO4. Now let's again see the balance thing. So we have PO4, OH, calcium and hydrogen, and we have reaction and product. So we have PO4 here 2 piece. So we have PO4 2 piece, right? This guy is 2 into 1, this guy is 1 into 2. OH part is 3 into 2, 6. OH part is 6 into 1, 6. Ca part is 3 into 1, 3. Ca part is 1 into 3, 3. Now left with hydrogen. Hydrogen here is 3 into 2, 6. Here 6 into 1, 6. So you see everything is balanced. Thus I can say that this is my balanced chemical reaction. Correct? Now let's take some more example. Here you write a balanced chemical reaction for hydrogen plus chlorine is equal to hydrogen chloride. So we have hydrogen, we have chlorine, both two gases, right? We know that H exists in H2 form, chlorine exists in Cl2 form. This gives HCl. Now it is not balanced, you have to balance it. So the order will be first chlorine and then hydrogen. Correct? So chlorine, if you see there are 2 chlorine items, there are only 1 chlorine item here in product. So let's multiply this guy with 2. So what you get is H2 plus Cl2 is equal to 2HCl. Now let's compare the chlorine and hydrogen part. Chlorine, they are in reactant, they are 2, and product they are 2. Hydrogen reactant 2 and product 2. So if you see that, it is a balanced chemical equation. Easy question. The only thing that you should know that hydrogen is H2 and chlorine is Cl2. We'll take some more examples. We have tried the balanced chemical equation for barium chloride plus aluminum sulfate is equal to barium sulfate plus aluminum chloride. So the equation is like this: barium chloride, aluminum sulfate. So I expect that you know what the formula of aluminum sulfate is equal to barium sulfate. I expect that you know the formula of barium sulfate plus aluminum chloride, AlCl3. These things we already know the formulas of various compounds. These compounds are familiar to us, so we just wrote this formula. Now let's see if it is balanced or not. First, any compound we have, yes, SO4. Then any metal, yes, we have aluminum and barium. Then we have any non-metal, yes, chlorine. These are the 4 things we have. So let's balance this now. To balance this, first see this is my reactant. Let me write here actually. So I'll use this only actually. So this is my reactant, this is my product. So sulfate we have 3 here and we have 1 here. Correct? This is not balanced, so you have to multiply this guy with 3. Correct? There are 3 sulfate, there are 1 sulfate here. So let's multiply. So what you get is barium chloride plus aluminum sulfate is equal to 3 barium sulfate plus aluminum chloride. Now let's again check. So we'll again check that. So we have SO4 here. So sulfate we have 3 here and 3 here. Aluminum we have 2 here and we have only 1 aluminum here. So it's not balanced. So let's multiply this guy with 2. So now what you get is barium chloride plus aluminum sulfate is equal to 3 barium sulfate plus 2 aluminum chloride. Correct? Let's again see it is balanced or not. So we have sulfate, we have aluminum, we have barium. So sulfate we have how many? 3 here and 3 here, balanced. Aluminum we have 2 here, 2 here, balanced. Barium we have 1 here and 3 here. It's not balanced, right? So we have 3 here and we have only 1 here. It's not balanced. So what we'll do, we'll multiply this guy with 3. So what you get is 3BaCl2 plus Al2SO4 3 is equal to 3 barium sulfate plus 2 AlCl3. Now let's again check. So we have SO4, Al, Ba and Cl. Correct? This is my reactant, this is my product. Sulfate part is 3 here and 3 here. Aluminum part is 2 here and 2 here. Barium part is 3 here and 3 here. Chlorine part is 3 into 2, 6 here and 2 into 3, 6 here. So we see that they are all balanced. This guy is my balanced chemical equation. Same thing, the only thing is that they are checking if you know the formula: barium chloride, aluminum sulfate, barium sulfate and aluminum. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on chemical reactions and equations part 6 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 5. We'll take one more example. Barium chloride plus potassium sulfate is equal to barium sulfate plus potassium chloride. So we have barium chloride plus potassium sulfate. That gives, potassium chloride plus barium sulfate. This is my formula. I have to balance this now. So here we have any compound, yes, sulfate. That's my first priority. Then we have barium, then potassium, right? And then we have chloride. So let's balance this. So we'll check that sulfate part, if you see, is in both cases we have 1, 1, it's balanced. Barium part is again 1, 1, balanced, 1 here, 1 here. Potassium part is 2 here and 1 here, so let's multiply this guy with 2. So what you get here is barium chloride plus K2SO4 is equal to 2KCl plus BS. Now let's see the equations. Sulfate part we have 1 here, 1 here, balanced. Barium part we have 1 here, 1 here, balanced. Potassium we have 2 here, 2 here, balanced. Chlorine part we have 2 here and 2 here, balanced. So if it is a balanced equation, and that is my answer. There is a calcium hydroxide, that is CaOH2. Carbon dioxide CO2 gives calcium carbonate CaCO3 plus water. Let's again balance this. So OH part is here, here, no, it's not there. So there is no compound kind of stuff here. So we'll first take calcium, then carbon, then hydrogen oxide. Correct? Makes sense? So we'll see the calcium part. Calcium part is 1 here, 1 here, balanced. Carbon part 1 here, 1 here balanced. Hydrogen part 2 here, 2 here balanced. Oxygen part 2 here plus 2, 4 here, and here we have 3 plus 1, 4. So both are balanced. If you see that, this is a balanced equation itself. You don't need to balance. What equation you got is a balanced equation. Zinc plus silver nitrate gives you zinc nitrate plus silver. So if you see, there is an NO3 part here. So first part will say NO3. Then metals we have zinc and silver. This is the order of my priority. We'll check first. This guy has 1 nitrate. This guy has 2 nitrates. We'll multiply this guy with 2, right? So what you get is zinc plus 2 AgNO3 gives ZnNO3 2 plus silver. Now let's again check. This is nitrate, silver and zinc. Nitrate we have 2 here, done deal. Silver we have 2 here, 1 here, right? So it is not balanced. Let's multiply with 2. So what you get is zinc plus 2 AgNO3 gives zinc nitrate plus 2 silver. Let's again see the count. So nitrate, silver and zinc. Nitrate is 2 here, balanced. Silver is 2 here, balanced. Zinc is 1 here, balanced, right? So if you see, it's all balanced. Thus I can say that this is my balanced chemical equation. Simple questions only. We have aluminium plus copper chloride. You should know the formula. That's all. CuCl2 gives aluminium chloride AlCl3 plus copper, that is C. Let's balance this. So if you see, this guy has we have metals such as aluminium, copper, and then we have chloride as non-metal. This is my order of priority. Correct? So let's check the aluminium part. Aluminium is 1 here, balanced, right? Copper is 1 here, balanced. Chlorine is 2 here and there is 3. So what I can do is I can multiply this guy by 3 by 2. So what you get here is aluminium plus 3 by 2 copper chloride, aluminium chloride plus copper. So now if you see my equation, aluminium is 1, both side 1. Copper is 3 by 2 here and 1 here. So we'll multiply 3 by 2 here. Right? 3 by 2 and 1. So we'll multiply this guy with 3 by 2. So now what you get is aluminium plus 3 by 2 copper chloride gives aluminium chloride plus 3 by 2 copper. Now let's again check the values. Aluminium, copper and chloride. Cu. So aluminium here is 1, here is 1, balanced. Copper is 3 by 2, 3 by 2, balanced. Chlorine here is 3 by 2 into 2, 3. Here we have 3. It's all balanced. Balanced, but in the fraction, so the denominator is 2 here, so we'll multiply with 2. What you get is 2 aluminium plus 3 copper chloride gives aluminium chloride plus 3 copper. And that is my answer. Easy only. Let's take one more example. Write a balanced chemical equation with state symbol for the following equation. Here we have to get the state symbol also. Sodium hydroxide in water, that is NaOH in water, reacts with hydrochloric acid, that is HCl is a liquid, to give sodium chloride solution. So sodium chloride solution is nothing but an aqueous solution in the water plus water. Correct? So this is my equation. And if you see this, it's already balanced equation. Sodium is 1 both side, oxygen is 1 both side, hydrogen is 2 both side, chlorine 1. This is already a balanced equation, and that is my answer. The extra thing is that we have to write the states here. So sodium hydroxide, it was a liquid. Then we have this hydrochloric acid, we got sodium chloride, NaCl and water is aqueous solution because the NaCl is dissolved in water, and we got water. Here also we write with symbols. Barium chloride, that is BaCl2, that's aqueous solution, plus sodium sulfate Na2SO4, that's again a solution, that is a solid actually. Sodium sulfate is a solid thing, reacts with in water. Sodium sulfate is a solid thing in water, so you can say it's an aqueous thing actually, because sodium sulfate is in water, so it's aqueous. It gives an insoluble barium sulfate, so you get barium sulfate, that is a solid because it's insoluble, plus sodium chloride NaCl. Correct? So we have this barium chloride aqueous solution. Then we have sodium sulfate, is solid actually, and that is put in water, but it's solid. So you can make it solid only. Here's the barium sulfate, that is again solid, insoluble in water, and solution of sodium chloride. So that's what we get. So if you see that is the unbalanced equation, we can just balance it. So here we see that SO4 is there, first priority. Then we can take sodium and barium, and then we can take chlorine part. SO4 one here already balanced. Sodium 2 here, 1 here not balanced. So we'll balance this by multiplying it by 2. So let's see the equation now. The equation is BaCl2 aqueous with Na2SO4 is again solid, gives BaSO4 solid plus 2 NaCl, that's aqueous. Now again see if it is balanced or not. We have SO4, Na, Ba and Cl. Sulfate is 1 here balanced. Sodium is 2 here balanced. Barium is 1 here balanced. Chlorine is 2 here and 2 here balanced. Right? So it's a balanced chemical equation, and that is my answer. So once we are done with balancing of chemical equation, we know what the chemical equation is, and we also know that the chemical equation has to be balanced, right? And we know how to balance the chemical equation. We had done. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on chemical reactions and equations part 7 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 6. A good number of exercise for that. Let's see the type of chemical reactions actually. So typically there are 5 types of chemical reaction. The first is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and combustion reaction. There are 5 kind of chemical reactions we have. There are other types also, but they fall in this type. For example, I'll tell you, typically any chemical equation you can see, by looking at the equation you can say that this is one of the type. Correct? But there are other types of chemical reactions also, that is based on the property. Redox reaction is whether oxidation is going on or reduction is going on. We'll explain this. Acid base reaction, that is whether the reaction is between acid and base. Acid and metal reaction. Exothermic, endothermic, that is whether the reaction is giving out heat or we have to provide heat for the reaction. Precipitation reaction, whether you get precipitations from that reaction. Catalysis reaction, whether catalysis is required or not. Biochemical reactions, organic chemistry reactions, photochemical reactions, solid state reactions, corrosion reaction, ratification reaction. There are so many reactions type, but all of these reactions type will fall into that 5 reactions which I have explained, right? So we'll go through all these kind of reactions. We'll see that all these reactions, right? Redox reactions, it can be exothermic redox reactions, it can be any of these, displacement or combination. The five basic types which we talked about in the previous slides. These reactions can be any of those reactions. So basically what I'm trying to say that given any chemical equation or given chemical reaction, it has to be one of those 5 types which we have discussed in the previous slides. So let's discuss those 5 types. The first is the combination reaction. The combination reaction. Before I go for the combination reaction, let me go to the analogy of combination reactions. So the general form of combination reaction is you have 2 chemical A and B. It combines to form chemical AB, and there may be some thing required. For example, heat is required or something. External thing is required, right? Extra condition. But general logic is you have 2 chemicals that combines or synthesize to form AB. So the analogy is there's one guy, there's another guy. There are 2 guys, you can say A and B. Now they both like chemistry subject, and if you see that, they become best buddies. So this is one compound. So there was 2 compound A and B. There were 2 students A and B, and they become one identity. That is, they became best buddies, right? So there was one compound A, one compound B, if you see, and they became best buddies because of the chemistry subject, right? So if you see, there were 2 things, and that became one thing. That is the example of synthesis or combination reaction. Sometimes you need external factor. For example, chemistry subject is one external factor we have that made these guys best buddies. Sometimes even that is not required. They just become best buddies. So in the form of chemistry, again, we'll touch upon this definition of the same reaction, combination and chemical reaction. We'll see this concept from a chemistry lens. So we have 2 elements that combines to becomes AB. So the description is 2 chemical species combine to become a single compound, right? So we have 2 chemical species they become a single compound. That is example of a combination reaction. For example, you have a quicklime and you add water to it, it becomes shake lime. So if you see, there are 2 elements here. One was a quicklime, one was the water, and it combined to become a shake lime. That is, CaO was my quicklime, the solid. You give water to it, it becomes COOH2 plus aqueous. And if you see, this guy gives heat also, right? It gives heat. So this is an exothermic reaction. So this is one of the reactions which you'll learn now, I mean, after some 10-20 slides. But what I'm trying to say is that this reaction is also another type of reaction also. For example, this chemical reaction, this synthesis or combination reaction can be another reaction also. So we have hydrogen plus oxygen. You combine these 2 molecules, you get water. So you have hydrogen gas, oxygen gas. You combine this, you get water. So you have 2 products, you get 1 product. So we have sodium and chlorine. You add these 2, you get sodium chloride. So you have sodium and chlorine. One was sodium was solid, chlorine was gas. You get NaCl, that is again solid. So you have magnesium and oxygen. You add these 2, you get magnesium oxide. This we have done actually. So you heat this, so you have this magnesium ribbon. So you heat this in presence of oxygen, you get magnesium oxide. This is also one combination reaction we have. We have 2 elements, you combine to get a single element. You have carbon monoxide and you have oxygen. You again heat this guy, right? So you get carbon dioxide. So that's again a combination reaction because you have 2 products and you got a single product as an output. So one more example, you have sulfur dioxide and oxygen. You combine these 2, you get sulfur dioxide and oxygen, you get SO3, that is a gas. So these are some examples of the chemical reaction which are combination chemical reactions or synthesis chemical reaction. The point here is that in all these reactions we have 2 products, you get 1 product out. We have 2 products, 1 output. 2 products, you get 1 output. You have 2 inputs, you get 1 output. So the reactant part has 2 items and the product part is 1 item. That's the example of synthesis chemical reaction. Let's do an activity for that. So what I can do is we can take some amount of calcium oxide or quicklime in a beaker. So this is a beaker and we have taken some lime in this. Slowly add some water to it. Let's add some water. If you see, right, this thing got dissolved. This thing got dissolved, right? So if you see, the moment we add water, this thing got dissolved. And now let's touch the beaker. And what you will notice that it's hot. This is hot. So what has happened here? So we have this CaO, the lime we have, quicklime, on this we added water. This gave aqueous solution. This is the aqueous solution actually with the CaO, and it gave heat also. So if you see, two items became one item, right? And this is an example of my synthesis chemical reaction. Correct? So where we have two inputs, A and B, it gives you new output called AB. One product. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on chemical reactions and equations part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 7. The next is decomposition reaction. Let's study the analogy of this. So they were two best buddies, now they're just one identity, two best buddies, and they fought over some topic. I don't know, maybe they got less, one got less marks, something. They just fought, and now they are two different people. So they were one identity called best buddies. They fought in the real life, right? They fought and they became two different identities. This is similar to what we have a decomposition chemical reaction in the chemistry world. So we have this one compound AB, you decompose to becomes two compound. So the description says a single compound decomposes to become two or more chemical species. It may be more also, it can be C and D also. The concept here is one compound and then breaks into multiple compounds. So for example, you have water, you pass some electricity to that, and that becomes hydrogen and oxygen. So on electrolysis, so this is electrolysis, this water as a one compound breaks into two smaller compounds. Use hydrogen peroxide again, that is converted to hydrogen water when you pass something. We have copper carbonate, they can heat, I think you heat this guy, it becomes copper oxide and carbon dioxide. You have ammonia, you can convert this to nitrogen and hydrogen. So one compound into two small compounds. So you have nitrogen triide, you can convert into nitrogen and iodine. So these are the chemical reactions where you see the common thing is you have one big compound and this got combined into smaller species. This is an example of decomposition of chemical reaction. Correct. For activity, what we can do is we can take 2 grams of ferrous sulfate crystals in a dry boiling tube. This guy is a boiling tube. Here I have ferrous sulfate, right? 2 grams. We note the color is blue. Now heat this over a burner. So let's heat this over a burner. But we'll observe that this color changes to red, right? So we'll observe that the color change to red also will see the pungent smell. The smell comes out, right? This is the nose we have. Smell comes out. There are two things. One thing is the color change and you get the smell. So if you see, this was my original compound and this is my new compound, right? This is my new, this is my old compound. So what do you see? What happened here? This guy was my ferrous sulfate. This is the blue one. When we heated this guy converted to Fe2O3. You got this gas also, and this gas is nothing but a pungent gas which you got. So in this, if you see, one compound is converted to multiple small compounds. This is a typical example of a decomposition chemical reaction where bigger compound is decomposed into smaller compounds. We'll take a more activity. So we take some 2 grams of silver chloride. This is the silver chloride. And we'll note the color. We'll put this in the sun for some time. So we'll have a stopwatch. Maybe after 1 hour we see that. We see that the color changes. It was white, it became gray, right? So let's see the color changes. Why the color changed? Because if you see now, earlier it was AgCl, silver chloride. On sunlight, this broke into silver and chlorine. This is the silver now, and we got chlorine gas. The gas evaporated. So if you see, this compound broke into 2 smaller compounds. And this is also one example of decomposition. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.